So today let's talk about a component called op-amp. Let's explore it. So the op-amp has two input terminals and one output terminal. The inputs are called non-inverting and inverting input, and output is called output. The inverting input is symboled by plus sign and non-inverting input is symboled by negative sign. And the way the op-amp works is that it compares the voltage between non-inverting and inverting input, and basically if the non-inverting input is higher than the inverting input, the output is going to be high, and if the non-inverting input is higher than the inverting input, the output is going to be low. So it can be used as comparators. So let's say the 5 volt is coming to its non-inverting input and the inverting input is at 0. The output is gonna go to the supply voltage, not to the 5 volt but to the supply voltage, and the current will be amplified. And let's provide the inverting input with 6 volts. Now the output of the op-amp will go low because the inverting input is higher than the non-inverting input. So that's the behavior and the nature of the op-amp. And the op-amp is a linear device, so we can use it linearly. We can connect the inverting input of the op-amp to the output, and the circuit will look something like this. This is the circuit I was talking about. We have connected the inverting input to the output, and if you provide the non-inverting input to any voltage, the op-amp will follow it. Since op-amp is a linear device, it can be used as comparator. So that means it has high gain, so we can use it as amplifier also. So this is the voltage amplification circuit, and it is very simple. Basically we are connecting a resistor divider at its feedback. If we connect the both resistors same value, then we will have gain of 2. So now let's provide the op-amp with 12 volts. So the 12 volt is coming to its non-inverting input. So what is gonna happen is that the output is gonna rise and rise, and it will rise until this inverting input will reach 12 volts. Basically op-amp will try to have equilibrium between both of its input. So if 12 volts is here, 12 volts must be here to keep the op-amp in equilibrium, and it will do anything to keep those input same. So if 24 volts is coming to the op-amp, then 24 into 2, 48 volts gonna come out of the op-amp, because then the 48 volts divided by 2 is 24 volts. So the 24 volts will be at its inverting input and 24 volts will be at its non-inverting input. So now let's talk about how op-amp works. So here's the schematic of op-amp. Simple op-amp, a very discrete op-amp. It is not very perfect, but anyways, here's its inverting and non-inverting input, and here's its output. I can mark here. So now what I was saying is that if you provide the non-inverting input with 5 volts, there is gonna be around 0.7 volts voltage drop across the base to emitter of this transistor. So what is gonna happen is that there will be around 4.3 volts at the tail, and the current will flow through this transistor and some current will flow through this resistor. So here it will be 4.3 volts, and the output is gonna go high because there will be some current flowing through this transistor, which is gonna turn on. Now if we provide this transistor with 6 volts at its base, what is gonna happen is that there will be more than 0.7 or 8 volts. There will be more than 0.7 volts across emitter to the base, and it is gonna turn on this transistor harder. It will source current from this resistor and fill it to the tail, and 6 volts minus 0.7 volts is around 5.3 volts, and so there will be no voltage drop across base to the emitter. So this transistor is gonna turn off, and it is gonna turn off this transistor, so the output is gonna go low. And we can also use it as a linear circuit by connecting inverting input to the output, and whatever voltage goes to the non-inverting input will come out at its output, and this is a very basic circuit. It is not very perfect. It will have high impedance at its input. There is gonna be high current flowing through these resistors, but somehow this circuit works. And of course the circuit is not very perfect. We can increase this resistor to decrease the input impedance. We can omit this resistor and connect directly to the voltage supply. We can also omit this resistor and rely on this transistor. So basically the full current will flow through the emitter to the base through this transistor, and it is gonna turn on this transistor harder, so there will be more current at the output. But this is a very crude circuit. We can modify it by using a current mirror, and we can use it in our circuit, and we can improve the circuit even more by using Darlington pairs here. But first let's talk about the current mirror. The current mirror is very simple. We connect the base to the collector of one of the transistor, and we connect the base of this transistor to this transistor. So basically what happens is that if some current is flowing through the collector of this transistor to the load, the same current will flow through this transistor to the load. So in this circuit I was using 100 kilo ohms resistor, and I calculated the current to be 83 microamps flowing through this transistor and to this transistor. 83 microamps, not milliamps or ampere. So we can modify the circuit, and we can connect the circuit here. You can see the current mirror. So basically this is also a very crude amplifier, a crude op-amp. This is the positive and negative or non-inverting and inverting input. And what happens is that if we provide some voltage here, it is gonna source some current from this transistor and fill it to the tail, and so this transistor turns on, which turns on this transistor. And if we provide some voltage here, then this transistor will turn on and it will source the current from this transistor to the tail. But of course there will be some voltage at the tail. So let's say we are providing this transistor with 4 volts. 4 volts minus 0.7 volts is gonna be 3.3 volts at the tail. So the output is gonna go high because it is sinking some current from this transistor. So this transistor is also gonna turn on. And if we provide 5 volts here, 5 volts minus 0.7 volts is gonna be 4.3 volts at the tail. So this transistor is gonna turn off, and this transistor is also gonna turn off. But what is gonna happen is that there will be voltage here, some voltage. It will not go to the ground, but there will be some voltage around 4.3 volts. So this is not the practical circuit. So what we gonna do is that we are gonna introduce another transistor, PNP transistor here, and now this input of the op-amp becomes the non-inverting input, and this one becomes inverting input. And if we provide some signal here, let's say 5 volts of DC voltage is coming to its base, 5 volts minus 0.7 volts, 4.3 volts will be at the tail, and the current will be flowing through this transistor from the emitter to the base, and this transistor is gonna turn on and the output is gonna go high. And if we provide around 6 volts at the inverting input, so 6 volts minus 0.7 is gonna be 5.3 volts. So this transistor is gonna turn on, and it is gonna turn off this transistor, which is gonna turn off this transistor, and it's gonna turn on this transistor and this transistor. So the output will increase here. Basically the voltage will increase here, but the voltage will decrease here. So that's how it works. Basically you are shunting this transistor using the current mirror, and it is gonna be more linear. It is gonna have more gain than this circuit. and then this circuit. This circuit is gonna have very low gain, but this circuit is gonna have very high gain, and we can modify the circuit by connecting many Darlington pairs at its input. You can see the Darlington pair. We can again connect the transistor here. We can increase the resistance to 100 kilo ohms, so there will be some microamps flowing to the base of the transistor, and we can also connect a Darlington pair at the output of the op amp, and we can connect this output stage class B amplifier, and it is gonna amplify the current, and this Darlington pair with these two transistors are gonna amplify the voltage and current. And then we can probe the output, we can use the output, we can make our oscillator using this, we can make audio amplifier or whatever which can be made using op amp. So this is the basic circuit of op amp, from a very basic circuit to a precise circuit. And of course the current mirror also have some flaws which I have not talked about. If the both transistors are matched, the same current flow to the collector of the transistor, but of course in real world the both transistors will have some dissimilarities, so there will be unequal current flowing to the transistors, which we can adjust by connecting higher resistance here, and then we can connect a potentiometer and adjust that which transistor will conduct more current and which transistor will conduct less current. But anyways, this was the video about op amps. We can also build op amp on breadboard, and we can also talk about the output of the op amp. The op amps are using silicon transistors which have around 0.7 volts of voltage drop between its emitter to the base. So what we are doing is that we are connecting an oscilloscope, and basically any voltage lower than 0.6 or 0.7 volts the transistor does not conduct, so basically the output is low. And if we increase the voltage above 0.7 volts, then the transistor will start to conduct, and this transistor will also start to conduct, and then it will work nicely. But then we also introduce class B amplifier, and we are biasing the transistor with two diodes, basically to avoid crossover distortion. Let's say a sine wave is going to the class B amplifier, so if there were no diodes connected, the output will look something like this. So to make the circuit more linear, we have to pass some current to these transistors so they work perfectly and linearly. So we introduced two diodes here, but of course we were connecting the diodes to solve a problem, but now there is another problem. Now the output of the amplifier can no longer touch the supply voltage rail, so it will settle to some voltage. Basically 1.2 volts is the biasing voltage for these two transistors. So if you are having 12 volts minus 1.2 volts is gonna be the output voltage of the amplifier. So that's the output graph of the amplifier. And of course we can modify the circuit, and we can make an amplifier which can actually touch the supply voltage rail, and then it will be called rail to rail voltage op amp. So that's the basic of the op amp, basic circuits using transistor